Starting at the back of the machine, we have what appears to be a fairly conventional shock absorber. I'll pull the boot back, you can see what I mean.
Yeah.
It's a little shock absorber.
Yeah.
Mounted to the bumper. No pivot points. It doesn't move. It's mounted rigidly to the bumper. If you come up front, there's another one up there.
Check, that's pretty cool. Nothing moves there.
The system works, you need two of these little shock absorbers, front and back. This technology is coming from automobile, and probably the most common vehicle in North America that you'll find it on is the Toyota Corolla XRS, the sporty Corolla.
Yeah, okay.
If you flip the hood, you'll find a little damper between the shock towers, and there'll be another one up under the rear bumper. There's approximately 15,000 of these systems coming onto the market every month now in automobiles. You won't read about it too much. The automakers don't talk about it. They just talk about having a great handling vehicle. So it brings to mind, okay, what the heck is two shock absorbers mounted rigidly to the frame, not moving, going to do? I think everybody is somewhat familiar with the term of chassis damping.
Yeah, for sure.
When you think of the stuff that's going on inside the frame, car, snowmobile, this is the first time anybody's applied it to snowmobile. Yeah. But the fundamentals, the basics, the theory is the same. There's a lot of vibration, there's movement in the chassis, there's noise. Think about the little clappers on a door stopper. You hit it and it goes doing, you get a wavelength like that.
Right, like a resonance or
resonate, perfect point. It resonates like crazy, and there's not just one clap. There's all kinds of different resonance going on within the chassis. The chassis can be referred to as having a viscosity, having a certain resistance to movement with certain frequency.
Which eventually breaks it down almost, right?
Well, when you add that all together, if you could see it as light, the vehicle would be glowing kind of red with all this vibration and movement that's going on, but it's very high frequency, it's very low pitch, there's not a lot of movement involved. These shock absorbers are designed that they will react to very high frequency movements in a very small way. They can be measured in microns. At the most, they might move a millimeter or two in some applications. Wow. But the inherent fact, and most car guys will say, well, just make the chassis more rigid, make a stronger chassis, you'll fix any steering, any handling issues. That's what this little display is about here. I'll give you a quick example. The only reason we put this out here is we've got to imagine this is a traditional frame. You hit it, it vibrates, you can feel the vibration, you can hear it.
Like a harmonics or resonance again.
Yes.
Yep.
Here's our stiffer chassis. Here's the same chassis, but we've braced it.
So, okay,
you hit it, it moves the frequency up, but it still vibrates at the same level. Point being, it doesn't matter how stiff the chassis is, there's still inherent resonance in that chassis that needs to be dealt with. Yeah. If you can take it away, the final result's going to be something more like...
Oh, come on.
And
that's
there's
amazing.
No vibration in my hand, it just takes it away. Believe it or not, by doing that, this shock absorber has reacted and stopped that buzz. It has moved, even though you can't see the movement. But there's been a couple microns of movement in there.
Wow.
Now, what's that mean to a snowmobiler? This is where it gets hard to get your head around, but we've seen it in cars. Some of the effect of having this system, people that get car sick, don't get car sick so much anymore. The sound of the door closing changes. It goes from a thunk to a thunk.
Yeah.
More importantly, and where it really comes home on snowmobiles is in the handling. And where they find the biggest improvement in a car is in a bit of a bumpy corner, a corner that's not perfect smooth, but when the car's getting some input from a road surface, and it's into a cornering situation where there's G-force and other force going into the car, it tracks much straighter, the driver's not correcting for it as much. When we found it in our snowmobiles, and the one that shocked me is one of our test engineers, who I quite respect this guy, he doesn't sugarcoat anything. His test report in this, we normally rank the baseline machine, we'll give it as a 3 at any of our points. If we can say it's a 3.5, then we'll say an expert or well-experienced guy, he'll feel a 3.5. If it hits a 4, we figure just about anybody's going to feel a difference between a 3 and a 4, whether it's in a comfort or a ski effort or whatever that is. Our main test guy ranked the PD system in a bumpy corner as a 5. We never give 5s to anything, not unless there's a huge gain in some area. So that really got my interest. Now this is where the jury's out. I haven't driven that machine myself, and I'm not going to go out and say it's a 5 until I get to ride it. But having that guy tell me that, and what I did feel, because I did ride this system once, straight line, I could feel a difference.
Wow.
How much of a difference remains to be seen. We know in cars, lots of little things are benefiting from the PD system. The guys are getting more gas mileage. So how can it improve the gas mileage? Because that driver, within the same comfort level, is carrying more speed through the corners, so he's not having to re-accelerate to pick up the speed.
Right.
It translates into better fuel economy. So, okay. But the big benefit in the snowmobile is getting around a corner. What's referred to as snap roll, but you get energy loaded into the chassis, the ski comes up, and as it unloads, the ski comes back down.
Yep.
You're still in the corner, so the ski starts coming up again. Sometimes you go through that several times before you make it
Oscillation.
through the corner. The damper system takes a set, ski comes up, stays there, you rail the corner.
That's amazing.
This system is patented by Yamaha. It's owned and licensed by Yamaha to several automobile companies. Toyota's one, Nissan's another. Right now there's 3 aftermarket companies it's been licensed to, TRD, Toyota, Nismo, and a company out of Japan called Cox that builds kits for Volkswagen and Audi and some of the other makers.
Now, that wasn't on these machines at the sneak peek.
No, this is something we dabbled with this season, and normally any of us will keep it a big secret until the next model year. What we learned from the cars, this is hard to understand. There's nothing to see. It doesn't make sense really.
Yep.
Guys kind of get, okay, you're taking vibration up, but what does it really mean to me?
Right.
So it was suggested by the engineer that developed this system, who's now working very closely in Snowmobile. Just throw it out there. Let guys start talking about it, think about it.
That's great.
And give them a chance to digest it, because it takes some digesting. That's why I'm reluctant to sit here and say, guys, everybody needs this. I wouldn't do that, because I don't know myself.
Well, let's see what it does.
Let's see what it does. So we're going to get them out into the market. If you get a chance, call me, call John. We'll get you a system. You can try it out.
Right on.
We've only got calibration right now for the Vector, but by the time Christmas rolls around, we'll have settings for Apex, for Venture.
Oh, I see.
We'll get them on the snow, and the more guys that can get on it, the better the feedback's going to be, and we'll decide whether we go forward from there.
All right.
If it's get well received, then yeah, we'll start putting it on our snowmobiles. At the end of the day, this will help a wimpy chassis or a stiff chassis, and about by the same amount. It's not like the stiffer chassis is only going to get a little improvement, and the Toyota will get a huge. It's about the same. Wherever you start, you get this much better.
Yeah, wow. Yep.
The part I'm curious about, and I asked the same engineer, is how much will it affect a snowmobile? Will it be more than a car or less than a car? Think about it this way. Engineers have put a lot of effort into chassis damping in cars already. They blow foam cores between sheets of metal. They add metal damping. They add material to try to absorb vibration and quiet it down. We've never done that with snowmobiles. So as far as that goes, snowmobile stands to gain more because nobody's done anything about it yet.
Wow. Very good.